I'm a little bit off today. So this is problem number 11 on the study guide. We just found the domain, and we said if we start highlighting here, we can't stop here because it has an arrow here on the function. So I keep highlighting to the left, same thing to the right. That means that my domain is from negative infinity to positive infinity. And we do less than on both because we never catch up to infinity. So we cannot include them. There it is. Now I'm switching to the range. The range, I'm going to start from the bottom to the top. If I start down here, does it start there? No, because it has arrows. So that means I would continue highlighting the whole paper. But then I highlight all the way up, and where does it stop? About right there. So it stopped at -1. Hands if you agree with that. Over here it didn't stop, it kept going to negative infinity. So my range was negative infinity, less than f of x, less than or equal to -1. Hands if you got that. Okay? Sorry? The -1? Aren't these numbers less than -1? Look at this one. Here's -1. If there was x, negative infinity is over here. Do you see it? Yeah? All right. So, set notation, solution set of f of x such that negative infinity less than f of x less than or equal to -1. Interval notation, parentheses, negative infinity, comma, -1, bracket. Hands if you got that. All right. Piece of cake? Yes? Yes, Mr. Q. All right. So let me talk about end behavior. End behavior. Look up, please. Here it goes. Writing utensils down, look up to the screen. For end behavior, all they're asking is when you start inputting values for x, what's happening to x, number one, and then what's happening to y on both ends. How many ends does this function have? Two of them. One end on this side and another end on this side. I'm going to start from this side. Okay? Here we go. So, if I input 0 for x, we're at -1 of y. I go to +1 of x. Let me zoom in. +1 of x is -2 of y. 2 of x is, right here, it's at -5 of y. 3 of x is at -10 of y. 4 of x, and it continues on. So, what does that tell you about x? It's going to continue to what? To positive infinity. That is correct. So the end behavior for this side for x, we're going to write as x goes to positive infinity. Comma. Everybody with me? I first use 0. Next I use +1, +2, +3, and I said it's going to continue to what? Positive infinity. So here we go. When I use 0, what was y? -1. When I use 2, what was y? -2. When I use 3 of x, what was y? -5. When I use 3 of x, what was y? -10. What do you notice to the y values? It's approaching what? Negative infinity. So we would write f of x approaches negative infinity. So, am I done? No, that's only one end. Now I need to focus on the other. I'm going to switch colors. Here we go. So once again, 0, negative 1. If I get negative 1 of x, it gives me negative 2 of y. If I go to negative 2 of x, it gives me negative 5 of y. If I use negative 3 of x, it gives me negative 10 of y. So what do you notice about the x values? They approach what? Negative infinity. And as they approach, what happens to the y values? They go to negative infinity. Find me the end behavior for that type. Jake, what do I write? As x what? No, Jake. Jordan, help him out. As x what? Approaches positive infinity. That is correct. Oh, actually, no. Where is it approaching? Negative infinity. As x approaches negative infinity, f of x approaches what, guys? Negative infinity. That is correct. All right. All right, we're done with that one. Let's go to number 13. 13, or what? Which one is this? 12. Go to number 12. This one has everything combined in it. This one has plotting your points, writing your equation, finding the domain and range. Do number 12 by yourself. Ready? Go. All right, so let me plot the points as you're finishing up. Age 6, 45 inches. 6, 45 inches is about right there. 8 years old, 50 inches. 8, 50. Bless you. 10 years old, 55. 12 years old, 61. And 14 years old, 63. Okay, and have you got something like that? Yeah? And then you sketch your array. Let's see. I'm going to start at 0. Who went through 3 points and left 1 above, 1 below? Yeah, that's pretty even, yes? So if that's true, look up, guys. What is our y-intercept? 0, 0. X sub 1, y sub 1. Leo, which other point do you want me to use for the slope? 6 and 45. 6, 45. That's our x sub 2, y sub 2. All right. So our equation would be y equals mx plus b. Focus, please. Our y-intercept, we said it was 0, so I'm going to put plus 0 right here. Plus 0. Okay. I bring down the y, the equals, and the x. What's the only thing I need to worry about? The slope. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Blank, minus, and minus. So what is y sub 1? Y sub 2 is 45. Y sub 1 was 0. X sub 2 was 6. X sub 1 was 0. So my slope was 45 over 6. Let's simplify that. Can we divide by 3 top and bottom? Yes, Mr. Q. So that would be 15 over 2. So my slope over here, I'm going to write 15 over 2. Am I done, Demi? What would I write? F of x equals 15 over 2x. And I'm done. Do I need to write plus 0? No. So what was this problem talking about? It says, Bob recorded his height at different ages. So before we move on, look at the slope. Height in inches, ages. So you know what the slope means. What does the slope mean? 15 over 2. What does that mean? Right, are you all right? All right, let's see. Joaquin, what does the slope mean? What does the slope mean? Every 2 years he grows 15 inches. Hands if you agree with that. That is correct. Let's go. All right. Are we done? No, we need the domain and the range. Domain and range. Hands if you already found domain and range. All right. So if I highlight from left to right, my first point is this one. I highlight going to the right. Do I ever stop? No, it keeps going, so that means my domain is from 0, less than or equal to x. What else? Less than positive infinity. That is correct. Because it keeps going, yes? Set notation. Solution set of x such that 0 less than or equal to x less than positive infinity. Interval notation, bracket 0, comma, positive infinity, what? Parentheses, that is correct. Hands if you got that. Okay, I see some hands, all right. Let's go with the range. I'm going to switch colors. Now I'm going to start from the bottom to the top. The farthest point on the bottom is there again. I shade up. Do I ever stop? No, because it's arrow at the end and it means it keeps growing. So that means my range is from 0 to positive infinity. But now it would be what? Less than or equal to f of x less than infinity. Solution set of f of x such that 0 less than or equal to f of x less than positive infinity, bracket 0, comma, positive infinity, parentheses, sorry. Hands if you got that? Yeah, we got this, yes? Did we fulfill all the points? Let's see, point C, sketch the best fit line through the data and write a linear function. Did we write that? Yeah, it's right there. All right. So, we covered a lot of stuff in that hour and a half. Show me where the framework how comfortable you are with functions, graphing, domain and range, and behavior. We got 4 is 5, 4 is 5, 4 is 5, 3.5. All right. Okay. Some of you are saying hi. Some of you need a manicure. Yes. All right. Okay, we're about to break, but before we go, hold on. Before we go, let's do number 13. 13 on the study guide. Last one before the break. Focus. If you have your colored pens, get those in front of you so we can use different colors for each step, and you remember the steps. Here it goes. Focus, please. Get your hat. My goodness. So, when changing to the inverse of a function notation, what is step one, everyone? Change it to y form. So I write y equals negative 2x plus 9. That's step one. Step two, I'm going to switch to green. What do I do for step two? Solve for x. Tell your neighbor again, what? Minus 9. We're left with y minus 9 equals negative 2x. Am I done solving for x? No. Divide by negative 2, divide by negative 2. Y minus 9 over negative 2 equals x. Step 2 is done. Step 3. Step 3 is important because this is when we do the inverse. What does that mean, Mr. Q? Well, all we have to do is switch the variables to make it inverse. So this will become what? X minus 9 over negative 2 equals y. Are we there so far? Am I done? No. I usually tell you to turn it around. So check this out. Look up, please. Turn it around. So I write y equals x minus 9 over negative 2. And what do we do at the end once we have it like that? Function notation. But now it's going to be the what? The inverse. So instead of y, we write f of negative 1 of x equals to this. X minus 9 over negative 2. Sorry? Box that and label that the inverse. Label this step the inverse. Okay, I did one with you. You're going to do one by yourself. Here it goes. This is example 13Q. Example 13Q. F of x equals 7x minus 2. Change that to its inverse. I'll leave the instructions or that little process right there. Let me zoom out. Focus, please, focus. And once again, the day of the exams, make sure you take your colored pens. It helps you remember the steps. That's just a tool for yourself. Okay? All right? There goes the process. See if you got it. Focus, please. Step 1, change to what? Y form. Y equals 7x minus 2. Step 2, solve for x. Plus 2 plus 2. We got y plus 2 equals 7x. Divide by 7. We got y plus 2 over 7 equals x. Step 3, we do the what? The inverse. That's when you switch these. So we get x plus 2 over 7 equals y. We rewrite it. Y equals x plus 2 over 7. And that becomes f of negative 1 of x equals x plus 2 over 7. Hands, if you got that? Let's go. All right, guys. So we're gonna step outside for a little bit over here in the parking lot. Make sure you stay away from the parking lot where the cars drive by. All right. You may use your phones off campus over there. And as soon as I see Ms. Munguia, I'll give you guys a call back. I'm gonna pause the video for a little bit. All right, here we go. Pads, please. Put away your mobiles, please. Appreciate it. Put them away. I'm going to take them away. All right, here it goes. Okay, we still have about an hour and 15 minutes. I think we're going to finish a little bit earlier than 11:30. Is that okay? Yeah, we're going to finish at 11:29, something like that. All right, here we go. All right, here we go. So, we did domain and range, is that correct? And behavior, is that correct? We did best fit line. We wrote an equation in function notation, given just points. I mean, we've covered pretty much everything. Now we need to get started with the transformations of functions. All right? So function review, here it goes. For function review, we started with, look up please. I started by giving you the first function such as this. Look up to the screen. F of x equals x squared. Right now you're just paying attention, please. Writing your pencils down. Nathan, can I have that, please? I understand. All right. We started with f of x equals x squared. There it is. And I said, to graph this, we need to make a table. And I said, x, f of x, and we usually use the domain -2, -1, 0, 1, 2. And this has been going on since 8th grade, is that correct? Something like that? I told you guys to always use that. So if we were to substitute these values in here, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. This is automatic by now, right? Especially those of you that we've been doing this already for a couple of weeks, nonstop. We wake up every day, a domain -2. However, now we're going to get into functions and transformations. You guys ready back there? Yes? Please, focus. So, if I gave you the transformation to use, which is g of x equals f of x plus 2. That was the first transformation that we started with. And I said, if we were to graph this, I'm just going to show you what it looks like. It's a parabola. Tell your neighbor what the plus 2 does to the whole function. Tell your neighbor, please. Yeah, by now you should know that it moves all the points, all these 5 points. Let me show you the points. It moves them 2 steps up. Each point you move them 2 steps where they're located up. That's what we transform. From there, I gave you the next transformation, which was f of x minus 2. Now that did something to the original function. Tell your neighbor what it does. This one moves the function to the right 2 steps, the whole function to the right. Now this is where some of you get confused. Look up to the screen. So Why is the confusion for this part? Here it goes. Here goes the general rule that I gave you guys. G of x equals a times f of 1 over bx minus h plus k. This is the whole thing. However, this rule right here doesn't have a k, so if I would to erase it, let me erase it. Does it have an a? The a is a invisible 1, so that's why we don't show it. It's an invisible 1. Does it have a fraction here? No, it's b is 1, so 1 over 1 is 1, so it's 1. So therefore, what is part of the formula? Part of the formula is a minus here, Mr. Q. All right, so here's the minus for the formula. So if this is part of the formula, what number did we substitute in here to make it look like this? Positive 2. If we substitute positive 2, that means we need to move this one to positive 2 of x at positive 2. That's when we move it to the right. All right. However, what if I gave you this rule? G of x equals f of x plus 3. Think about it. Look at the rule and tell your neighbor what number did we substitute in here to get positive 3 from. Everyone. Negative 3. So we substituted negative 3 because negative times a negative become a positive 3. So if we substitute a negative 3, that means we move the entire function to the left to the negative 3 spot of x, or 3 steps to the left. Are we there so far? All right. From there, let me erase this. Focus, please. Next, I gave you the rule g of x equals 2f of x. F of x are all these numbers. Here they are. That's what f of x indicates. But this tells us to do something. Tell your neighbor, what does it tell us to do? It multiplies the f of x, which makes the function stretch. If it's a whole number, it stretches and it becomes thin like that. It stretches. However, if a is a fraction, tell your neighbor what happens when it's a fraction. It becomes a little itty-bitty function. It compresses and it looks something like this. So far so good? Whole number on the a stretches, fraction number on the a compresses. All right. So, with that said, on your blank sheet of paper, write this down. G of x equals a f of 1 over bx minus, and make a minus noticeable, h plus k. All right, here we go. So, I'm going to use blue. I'm going to start with A. A stretches or compresses. When does it stretch the function? When it's a whole number. Or an integer, because sometimes it's going to have a negative in front of it. When does it compress? Fraction. And if you want to illustrate it for the sake of your notes, do this. I'm going to go to red now. Whenever we substitute values here for b, it either stretches or compresses. You're like, wait a minute, Mr. Q. Didn't we say that before? We hear, yeah, but this one does it vertical. It either stretches like this or compresses like this. Vertically. Vertically. So you remember when it compresses vertically, that's A. B does it which way? Horizontally. So stretches horizontally if it's a whole number for B. That means that it's going to look like this. And it compresses if it's a fraction, or decimal. And it's going to look something like this, which is very similar to this one, but smaller. And you're saying, Mr. Q, it looks like this one. Yeah, it's going to look pretty close to that one. All right? Remember when we went to decimals, we did the activity that you guys moved the levers and all that to show you how to do all the... Yes, Mr. Q. All right, good. Next, H. What does H do? It moves it to the right or to the left. It moves it to the right when we substitute in here a positive number. When we substitute a positive number for H, it moves it to the right. It moves it to the left when we substitute a negative number. So what does it look like if we substitute a negative number? It would be x plus a number, because negative times a negative becomes a positive. And last but not least, the K. Tell your neighbor what it does and how it does it, please. Yeah, it moves either up when it's a positive number or down when it's a negative number. Okay? All right. And last, before we move on to do some of those transformations, here it goes. Write your pencils down, look up to the screen. You're going to be getting some of these. G of x equals negative f of x minus 1 over 9. And some of you, when you saw this the first time, you're like, Mr. Q, that doesn't look like anything of the rules that you gave us. I say, but can we rewrite it? Yes, what did we say? What's in the invisible number here? It's a 1, so that means this we can get out of here, and it becomes g of x equals negative 1, 9 f of x minus 1. Everybody there? All right. Copy this next one. I want you to rewrite it, please, before we move on to do a problem. Example, mega Q. Write this down. G of x equals negative f of x plus 9 over 5. Rewrite that one, please, so it can look like the rules that we've been looking at. All right, so who wrote g of x equals negative 1/5 f of x plus 9? Hands if you got that. All right, now check this out. Look up to the screen. Now, why do we need to rewrite it like this, Mr. Q? Because this shows us one of the transformations, the easy one. Which is the easy one? The plus 9. Where is it going to move to? To the left 9 steps. So we don't have to worry about this part. What do we have to worry about? Negative 1/5 times f of x. So you're saying, oh, I see, Mr. Q, that's when we do an extra column on our table. Yes, that's when we do the extra column. Go to the study guide. Let's go to problem number 14. Number 14 on your study guide. Let me zoom in. It reads, look up please. It says, graph the function f of x equals x squared, then graph the transformation given by g of x as a transformation. So before we get started, what do we need to graph first? F of x equals x squared. Tell your neighbor what you need to do here in order to graph. Everyone? A table, that is correct. So then we do x, f of x. What values do we use for x? -2, -1, 0, 1, 2. By now you should be able to fill this table up by yourself, is that correct? Tell your neighbor how to fill it, please, with that rule. All right. So -2 squared is 4, -1 squared is 1, 0, 0, 1, 1, 2, 4. Let's plot those points. -2, 4, 1, -1, 1, 0, 0, 1, 1, and 2, 4. Sketch your parabola. All right, there it is. Piece of cake up to right there, yes? All right, now we need to do the transformation. So, this is what I want you to do. I want you to write this one over here, leave some space here, and I want you to write it over here. G of x equals negative f of x plus 8 over 4. However, does that look familiar? Kind of, but now I show you how to transform it. Is that correct? Change that, please, to something that looks more familiar. All right, here we go. What do we have? G of x equals -1/4 f of x plus 8. Hands if you got that. All right. So, by looking at it, which is the easiest transformation? The plus 8, is that correct? We're going to move it to the left 8 steps. So therefore, what do we need to worry about then? We need to worry about -1/4 f of x. So this is what we do. Look up, please. You do an extra column right here. And you're going to write -1/4 times f of x. So let me zoom in. Here it goes. What is my first value of f of x? 4. What is 4 times -1/4? It becomes -4 over 4, which is -1. Did you see what I did there? Next, 1 times -1/4 is -1/4. So you're saying, Mr. Q, why are you multiplying these times 1/4? Because this is what? F of x. What is f of x? All these values. So that's 0. What goes next, everyone? -1/4. And lastly, -1. All right, let's plot that transformation. Do that in red. Let me zoom in. So which is my first coordinate? -2, -1. -2, -1. There it is. What's my next coordinate? -1 and -1/4. -1, -1/4. What'd I do? Oh, -2 and -1. My bad. Be nice. -2, -1 is down here. Okay, there it is. All right. Next one, -1, -1/4. -1, Negative 1/4 is about right there, very close to the line of x. 0, 0, 1, negative 1/4, and 2, negative 1. So first of all, what do you guys notice did it happen? It compressed it, but also it did what? It inverted. Why? Because it has a negative on it. It inverts it. Okay. Are we done? No. Switch to blue, and now we're going to do the last transformation, which is 8 steps to the left. So I want you to move all those points 8 steps to the left. Let me zoom out. Hands, if you got that? Yeah, right? Tell me what we're about to figure out with this. 5 4s, 5 4s, 5 4s. Yeah, we're there, right? All right. That was number 14. Let's do some more graphing. Let's go to number 15. Go to number 15. Here it goes. It says, given the function and identify the domain and range. It says, graph the given function and identify domain and range. What do we do to graph? Everyone, a table. X. Do we write f of x? G of x. Negative 2, negative 1, 0, 1, 2. All right, so my first value is negative 2. If I substitute it in here, I should have what? Absolute value of negative 2 plus 2. So what is the absolute value of negative 2? No. What is the absolute value of negative 2? 2 plus 2? 4. Absolute value of negative 1. 1 plus 2? 3. Absolute value of 0. 0 plus 2? 2. Absolute value of 1. 1 plus 2? 3. What do you guys notice? You notice 4? It repeats. Yeah, so the next one is 4. All right, let's pop those points. Negative 2, 4. Negative 2, 4. And notice these go by 2's, by the way. Negative 1, 3. Negative 1, 3. 0, 2. 1, 3. And 2, 4. All right? What do you guys notice? It's a V. Yes, because it's an absolute value. So let's see. Are we done graphing? Yes. But what are they asking us to do now? Identify the domain and range. I'll have you do that. I'll give you some time. 45 seconds. By now you should know how to identify domain and range. Ready? Go. Copy that and go. All right, here we go. Domain. I'm going to use my highlighter. I'm going to start with the farthest point to the left. It would be this one, but there's an arrow there. What does that mean, Mr. Q? That I continue highlighting to the left? Do I ever stop? No, it keeps going. How about if I continue going to the right, will it ever stop? No. Therefore, my domain, let's see if we got it by now. Domain is from negative infinity to positive infinity. Hopefully you did less than x, less than positive infinity. Do they ask us to write solution set or interval notation? No, so we're done with that one. Box it in. So now we move on to the range. I'm going to switch my highlighter. Pink. Farthest point from the bottom to the top. From the bottom, I think the farthest point is right there. And if it has arrows going upward, it continues going to what? Positive infinity. Is that correct? What's the lowest point here? It is 2. So my range is from 2 to positive infinity. All right, so what did we write? Less than or equal to f of x and less than. And if you got that? Huh? Oh, my bad, it's g of x. Thank you, Manny. I did that to see if you guys are paying attention. There it is. Okay, show me your favorite how comfortable you are with these. Yeah, we got this, yes? All right, go to number 16, the last one of the functions and all that, and then we're going to go back and just cover the Algebra 1 part. That should be a piece of cake, okay? Here we go. It says, solve each problem using an absolute value inequality. Here you go with absolute values. Now, before I set this up, look up, please. Aldo, Ryan, you guys all right over there? All right, here we go. So our transformation formula, once again, was what? G of x equals AF 1bx minus h plus k. Is that correct? And what did I tell you guys in class? That now that we're covering absolute value, look up, please. We're not going to use parentheses for our formula. We're going to use what? Absolute value. Do you guys see where I'm getting this from? Do you guys see that part here? So the parentheses, what did I use? Absolute value. Here's the x and here's a minus. That means when we write, pay attention to this part, when we write equations or inequalities for absolute values, we always begin with absolute value x minus absolute value. From there, we need to write an inequality sign, and then we write a number right here, which is the one that becomes a negative and a positive. Are we there so far? All right, let me go back to problem number 16. It reads, the thermostat for the basketball gym is set at 75 degrees Fahrenheit. Oh, 76. But the actual temperature may vary as much as 3 degrees Fahrenheit. What is the range of possible temperatures? So they want us to write an absolute value inequality. So what is the first thing we write? Absolute value x minus absolute value, and we need an inequality sign. Question, could it be more than 76 plus the 3? No, it has to be less than that. So we have to write less than or equal to. Next, we got to figure out which number goes up and down, or positive and negative. Is it the 3 or the 76? It's the 3. It says here, but the temperature may vary. How much does it vary? 3, either plus or minus. So that 3 goes right there. Next, the 76 goes inside, 76. And from there we write 2 inequalities. Here we go. Let's see. Question. And for those of you that are struggling with inequalities, check this out. Line down the inequality symbol. This will have you focus here and think about it. Is the absolute value by itself? What I'm asking is this. Is there anything in front of it, behind it, or under it? No. If it's by itself, at that point, we write 2 inequalities. One for negative 3 and one for positive 3. If it's for negative 3, who remembers what to do to the inequality symbol? Flip it. We flip it, write whatever's inside, x minus 76. This one stays the same, and we write x minus 76. Do we know how to solve that? Yeah. I'm going to do this one in red. Plus 76 plus 76. That means x is greater than or equal to 73 degrees. This one plus 76 plus 76. That means x is less than or equal to 73 degrees. Oh, it's 79, my bad. Yeah, I did that to see if you were paying attention. 79 degrees. All right. Let's see. Just to keep it consistent to what we've been doing, let's graph this. Okay? Here we go. Draw your graph line, your number line. Here it is. 0. Here's 73. And here's 79. I'm going to start with this one. Solid point. Now, this is where some of you continue making a mistake. Look up, please. Some of you just go, oh, it's going this way. No. Test a point. Which point do I always use? 0. So let's see. Is 0 greater than 73? It's false. So I'm not going to shade towards 0. That means I'm going to shade the opposite direction. Does that make sense? Let's go with the next one. Solid point at 79. Once again, I'm going to test 0. Is 0 less than 79? True, so that means I'm going to shade towards 0. What do you guys notice? It's an and. So write and. So now we are able to write our solution set. Here we go. Solution set of x such that, Jay, give me the rest. (73 degrees). Very good. Less than or equal to, everyone, x less than or equal to 79 degrees. This is the range of how much temperature will vary in the gym, from 73 degrees all the way to 79 and everything in between. Pretty simple, yes? Piece of cake? All right. Let me zoom out. Oh, I was zoomed out. All right, up to right there, we finished with the functions, transformations, domain, range, and all that. Show me your fingers how comfortable you are with all that so far. 5, 4, 5. Yeah, I'm expecting at least 90 to 100% on this first quarter assessment. Okay. All right. The next part, we're going to do Algebra 1. We're going to do the full review of the first portion, which is only, I think, 8 problems, and we should be done a little bit early so we can go home. But before we do, everybody stand up. Don't move from your spot. Just stand up, stretch. All right, Algebra 1, let's go to problem number 1. Problem number 1, it says, focus please, solve. Before I start with that one, tell your neighbor the first thing we need to do, please. Identify common denominator. What would be our common denominator for 30 and 6? 30. So we multiply everything times 30. So I'm going to multiply 30 times h, 30 times -3, and 30 times 1. So that is 30h over 30 minus 90 over 6 equals 30 over 6. Well, Mr. Q, why do we need to multiply times the common denominator? So we can simplify it and work without any fractions. Here we go. What is 30 over 30? 1h. Negative 90 divided by 6, that's 15. And 30 divided by 6, that's 5. Do we know how to solve that? Line down the equal sign, and what do? Add 15, h equals 20. Do we need another one of those? No. Tell me with fingers how comfortable you are with these. 5. Let's move on to number 2. Number 2. Here we go. Solving graph. It's an absolute value. Let me zoom in. Once again, guys, when you get to these with absolute values, draw a line down your equal sign so you can focus and leaving the absolute value by itself. Okay? Here it goes. Line down the equal sign. Here's the absolute value. What's next to the absolute value? Plus 4. So what do? Minus 4 minus 4. Absolute value of 5x minus 2 equals negative 2. Question, is the absolute value by itself? Yes. At that point, look up please, we would write 2 equations. Is that correct? But here's a red flag. What's the red flag? Negative. So what does that mean? We stop at that point and analyze this. We see absolute value gives us what? Positive numbers equal to what? Negative numbers. Is this true? No. So you cross this out because it's not equal. So what does that mean, everyone? No solution. Why? Because everything that comes out of the absolute value is positive, and this says that it's equal to a negative, and it's not true. Let's do another one of those. Example 2q. 2q. What's that? Yes. Absolute value, 2x minus 1. Close the absolute value. Plus 5 equals, give me a number? 9. Anyway. See if you can do that one by yourself. Solve it. And then I'll come right after and show you the process. Ready, go. Should have drawn a line down the equal sign, and then you saw that outside the absolute value it's positive 5, so we subtract 5 from each side. We get absolute value 2x minus 1 equals 4. Is there anything outside the absolute value anymore? No. We write 2 equations, one negative 4 and one positive 4. What's inside? 2x minus 1 equal to that, and 2x minus 1 equal to that. We solve. Plus 1 plus 1, 2x equals negative 3, divide by 2. I know, it's fun, right? X equals negative 1.5. This one in blue, plus 1 plus 1, 2x equals 5, divide by 2. X equals 2.5. Hands if you got that. All right, let's graph this. Since it's an equation, we don't need to shade. We just need to plot. Here it goes. Here's 0. Here's negative 1, negative 2, 1, 2, 3. So the solution for this one is negative 1.5, which is right there. The solution for this one is 2.5, which is right there. That's all we do for equations. But am I done? Solution set. Solution set, negative 1.5, comma, 2.5. Close the set. Yes? Do we need another one of these? No. Tell me the fingers how comfortable you are with these. 5. Okay, let's move on. Number 3. It says, solve and graph the inequality, then write the solution set. Let me zoom into the inequality. There it is. Once again, draw your line down the inequality symbol so you can focus on the absolute value by itself. Okay? So, step 1. Kaylani, what do? Add 6 to both sides. We're left with absolute value x minus 3 less than 8. Is there anything outside the absolute value on this side? No. So we write 2 inequalities, one for negative 8 and one for positive 8. remember to flip the symbol here for the negative. That is correct. Don't forget that, please. X minus 3. This one stays the same. X minus 3. Let's solve. I'm going to do this one in red. Plus 3 plus 3. We're left with x greater than negative 5. I'm going to switch to green. Plus 3 plus 3. X less than 11. Hands if you got that. All right, let's graph that. I'm going to graph that underneath. Is that crooked or a little bit? All right, here we go. 0. Negative 5 is right here. I'm going to start with the red one. It's an open point because it doesn't have the equal sign. Is that correct? What do I do next to shade? I need to test a point. What do I test? 0. Is 0 greater than negative 5? Yes, that's true. So I'm going to shade towards 0. Next, 11. Open point. I'm going to test 0 again. Is 0 less than 11? True. So I'm going to shade towards 0 again. So what do you guys notice? They overlap, so this is a what? And. Therefore, let's write our solution set. Solution set of x such that negative 5, what else? Less than x less than 11. And we're done. Let me zoom out. Show me if you're how come you are with these. Yeah, we got this, yes? Let's go to number 4. Number 4. All right. Here goes this one. This one, I don't know why you guys get confused. This is probably the easiest one. Writing your utensils down, look up to the screen. Josh, focus. Here we go. Whenever we write an inequality, we always start with a variable. I want you to check which variable they give us. What is that variable? So we write m. The second thing we write is our dividing point. What's our dividing point here? 1.5. Are we there so far? From there, we test a point. Which number do you want to test from the solution? 0. So I'm going to write 0 for m and 1.5 over here. If these two were on a scale, here's the scale. From here to here, it's even. Which one would be heavier? 1.5. That means this side of the scale will drop. That means the arrow will point that way. That means it would go that way. Is it a close point? It's open, so we leave it like that. This is our inequality. However, now that we know solution set, what would we write? Solution set of m such that m less than 1.5. Yes? Let's do another one of these, just to make sure we got it. Example 4Q. Example 4Q. Draw your number line. 0, 1, 2, 3, 4. It's shaded going that direction. And I'm going to label this one variable Q. Write me an inequality, please. Remember, if you're not sure how to write your inequality, check a point. That's the most important point that you should make. So like that, you don't have any problems? I'm telling you. And fuego. Answer. Q is greater than or equal to 3.5. Solution set of Q such that. Hands if you got that. That is correct. Hands if we need another one of these. Damien says another one. All right, let's do another one. Example 4, super Q. Yeah, Damien for Presidente. Example 4, super Q. Zero, 1, 2, -1. Solid point, shaded to the left, and I'm going to use the variable N. Okay, N as in Nancy. Oh, Nayeli, not that, or Natalie. Or Nintendo. Or Nutella. Nutella? No? Oh. What? All right, Sherry, when you're here, see what you got? Let's see, Audrey, what'd you get? I can't hear. And less than or equal to -1. Solution set of n such that. Hands if you got that. Yeah, we got this. Let's move on. Go to number 5. Number 5. Oh, yeah. Let's go. Solve by elimination. Let me zoom in. All right. Keyword here is what? Elimination. Tell your neighbor what that means. We start off by eliminating one of the variables. So the first thing you do, you get to these, draw a line straight through, and we're going to combine straight down like so. Which variable is going to cancel? The y. Y minus y is a 0 pair. -5x plus 3x, that's -2x. Equals -6. Let's solve. Divide by -2. X equals 3. Tell your neighbor why we're not done yet. We need to solve for y now. That is correct. Substitute into one of the two equations. Which one do I use, the top or bottom? All right, so I'm going to write 3 times x, but instead of x, I'm going to write 3 minus y equals 1. 9 minus y equals 1. Minus 9 minus 9. -y equals -8. Divide by -1. Y equals 8. Am I done? No, you need to write your solution. What's the solution? 3, 8. Why do we need to write it like that, Mr. Q? Because when we graph these, tell your neighbor what this means. What does that mean? Yeah? All right, let's see. Is Carlo here? No? No, you didn't make it? All right. Aaron, why do we need to write it as a coordinate? Sorry? Oh, ask your neighbor. Jade. Because when we graph both equations, what happens? That's where they intersect. Say never again, why do we need to write it as a coordinate? That's where they intersect. Do we need another one of these? Move on to number 6. Number 6. Here we go. It says, the Fun Guys game rental store charges an annual fee of $20 plus $6.50 per game rental. The game bank charges an annual fee of $50 plus $3 per game, $3.50. How many game rentals will the cost be the same for both stores? What is the cost? Write and solve a system. So how many different stores, guys? 2 lines down. 1, 2, 1 across. The first one is Fun Game, so I'm going to just put F. The second one's called the Game Bank, so I'm just going to put G. And here are total. So here we go. How much do they charge from the beginning of the first store? $20, so that's plus 20. How much per game? $6.50, so we write 650x. But since we need to write a two-variable equation, we write it as what? Y equals that. Write me the equation for the second store, please. All right? The second equation should have been y equals 350x plus 50. Hands if you got that. All right, so here we're going to write our system. Our system is y equals 650x plus 20 and y equals 350x plus 50. Let's solve this using substitution. This says that y is what? All this. So on the second equation, instead of writing y, what am I going to write? That. 650x plus 20 is equal to 350x plus 50. Does this look familiar? Yes. All right. So what do we do from there? Roman, go. Subtract 350x from each side. That is correct. Subtract 350x from each side. That leaves us with 3x plus 20 equals 50. And we finish it off. Minus 20 minus 20. 3x equals 30. Divide by 3. X equals 10. What does the 10 stand for? The games rented. So games rented. However, is that the only question they're asking? No, they're asking, what is the cost? Tell you here what we need to do with this to find the cost. Substitute into one of the two equations. Which one do you want to use? The first one or the second? The second one? Okay, I'm going to use the first. So instead of x, we write 10. And then bring everything else down. Y equals 650 times 10 plus 20. It doesn't matter which one you use. You get the same answer, yes? So this is y equals 65 plus 20. Y equals 85. And that stands for the what? The cost. Bless you. Are we done? No, this is a word problem, so you need to write a statement. Tell you never what you would write as your answer for this problem. The cost for both stores would be $85 after 10 rentals. 10 Q. Yes? Do we need another one of these? No. Okay, let's go to number 7. Number 7. Polynomials. Let's go. And guys, once again, we're reviewing polynomials because in I think next unit we're going to start with quadratic functions. So we need to know all of this stuff. Here we go. Look up. So, it says subtract. Look up, please. Subtract. This one has a subtraction sign, but there's an invisible coefficient here, which is a what? Which means we're going to distribute the negative 1 to each of these terms. So this becomes negative 1d to the fourth, negative 7d squared, plus 4. Bring these down by themselves. 3d to the fourth minus d to the second. Why didn't we do anything here? Because it's an invisible positive 1 and it stays the same. Now we can combine like terms. 3d to the fourth, is there another d to the fourth? Yeah, right here. What is 3 minus 1? 2d to the fourth. Next, negative d squared and negative 7d squared. So that gives us negative what? 8d squared. And lastly, we bring down the plus 4. Can we combine any more? No, because these have totally different exponents. We're done there. Show me where the parents how comfortable you are with these. 5. Move on to number 8. Number 8. Multiply. I'm going to use 2 different colors. I'm going to start with red. Circle the y. What is y times y? Y squared. What is y times 2? 2y. I'm going to switch to blue. What is negative 4 times y? Negative 4y. What is negative 4 times 2? Negative 8. At that point, we're going to combine like terms. Bring down the y squared. Combine the y's. What is 2y minus 4y? Negative 2y. Bring down the negative 8. We can't combine anymore, and we're done. How comfortable you are with these? 5 4s, 5s, 5 5 5s, okay? Y'all ready for the last one? And last but not least. What's that? Oh, second to the last. Yay. Back to the trinomial. Here we go. C squared plus 19c plus 90. First thing you need to check. What number divides each term other than 1? None. Therefore, Power Rangers. Last term goes on top, 90. That's our product. Middle term goes on the bottom. That's our sum. What factors of 90 add up to 19? 10 times 9 or 9 times 10? I'm going to do 9 10. 9 times 10. So I'm going to rewrite this again. C squared, but instead of 19c, I'm going to write what? 9c plus 10c, and bring this one down, plus 90. Group. What is GCS here? What number divides each term? C. We're left with c plus 9. Plus, what number divides each of these terms? 10. We're left with c plus 9. All right. What's the same here and here? C plus 9, that's one of the factors. What's left over here? C and here, plus 10, so C plus 10. And these are my factors. Tell me with your fingers how come you are with these? 5, 5, 5, 5, 5, okay. Do we need another one of these? Last one. Number 10. Woo! Let's go. All right, look at it. Notice that this one's very similar to the one we just did, but this one has a what? A coefficient of 3 here, which means we do this. Now we need to multiply the 3 times 15. That gives us 45. That goes right there. What's the middle term? 14. Factors of 45. 1 times 45. 3 times 15. and 5 times 9. Which one of those adds up to 14? 5 and 9. Let's rewrite this. 3x squared plus 5x plus 9x plus 15. Let's group this. These two, these two. GCF here is x, and I'm left with 3x plus 5. Plus. What number divides these two terms? 3, we're left with x plus 5. So what's the same for both terms? 3x plus 5, which is here and here. What's left? X plus 3, which is this one and this one. And those are our factors. So we go, yeah. Hold on. Question. Can't hear you. Forgot the 3? What? Oh, 3x. Sorry. Right here. There you go. 3x plus 5, 3x plus 5. Can we bring it up there with the study guide? We're good? Okay, I'm going to dismiss you by section. Yes, I don't want everybody rushing out. I know that you guys want to get to your saving the world or whatever you do. Okay? All right, we're going to start. Actually, before we dismiss, get your trash to the trash can, please, before I dismiss you guys. Oh, and by the way, I'm going to upload this video as soon as we're done here. Enjoy it. Later, guys.